Hello everyone, today we're going to be looking at Quantibus number 32, which is a really cool brain teaser optimization type of problem. And basically what's happening is there's this man who needs to transport 3,000 apples from town A to town B, and these towns are 1,000 miles apart. So he has this donkey with him that can carry at most 1,000 apples at a time. However, when the donkey is carrying apples, it will eat them at a rate of 1 apple per mile. They may drop any number of apples at intermediate points along the route and come back later to pick them up. So what is the maximum number of apples that they can deliver to town B? Okay, now to solve this, I drew a cool little diagram. Basically, we're in town A with 3,000 apples, and we're trying to go 1,000 miles over to town B. And the first thing to notice is that the donkey can only carry 1,000 apples at a time. So if we just loaded up the donkey and started sending it across, fully loaded with apples, well then it would get to town B with 0 apples because it eats the apples at a rate of 1 per mile. So we're just going to lose all of our apples if we do that. But the cool thing is that we can drop off our apples at any intermediate part along the route and come back later to pick them up. So what that means is basically, if this is my 500-mile mark, right halfway between town A and town B, and I load up my donkey with 1,000 apples, then I can go to the 500-mile mark and I can drop off 500 apples. I'll make this 1/2. This is halfway between the towns to make it less confusing. So I just dropped off 500 apples. And now on my return trip, I don't lose any apples because I'm carrying them. And I drop them all off here. And then I'm going to have 2,000 apples. So I load up my donkey to the brim again. And I bring it to halfway. So I lose 500 along the way. But I drop off 500 here. So now I'm at 1,000 apples. And I'm at 1,000 apples back home. So I go back, lose no apples, load up the donkey, and I lose 500 on the way, but I end up here with 1,500 apples. So now we would have 0 apples over here and 1,500 in the middle. Then we could load up our donkey to the brim again with 1,000 apples and send them straight to town B, losing 1 apple per mile, which would be 500. So we end up in town B with 500 apples. And then we'd have 500 at the halfway point. So notice that there is a way to get apples over to town B. However, when we go back to the halfway point to pick up the rest of the apples, we only have 500, which is half capacity, and we'd just lose them all in the 500 miles that we'd have to travel. So there'd be no point in doing this. What is the maximum number of apples that we can deliver? 500 is better than 0, but it's surely not optimal. So now what exactly was suboptimal about this run? Well, notice that when we had 500 apples at the halfway point, we loaded up our donkey halfway, and that is just not going to cut it. That's obviously not going to be optimal. We want to have our donkey at its maximum capacity as much as possible. Also, let's rewind back to when we had 1,500 apples halfway after doing 3 trips, right? Well, notice that since our capacity was 1,000, it took us 3 trips to get 1,500 apples. So we lost 1,500 apples and we only went 500 miles. So we're losing 3 times the amount of apples as we are traveling miles, even though the donkey is only eating them at a rate of 1 apple per mile. And the reason for this is just purely because the donkey has a poor carrying capacity, right? If it could carry 3,000 apples at a time, then we'd just lose 1,000 apples. We'd make the cross in one go and we'd end up with 2,000 apples. But the capacity is only 1,000. So also notice that once we got to the 1,500 apple mark and we did our trips, we didn't have to do 3 trips every time because we had a lot less apples. We only had to do 2 trips, even though one of them was suboptimal. So now notice that if let's say I had 1,000 apples, if we could find a point where I have 1,000 apples, then I only have to make 1 trip to get to town B, right? Which means I wouldn't be losing apples at a rate of 3x anymore. I'd just be losing them at a rate of 1x. So obviously there's some inflection point in here that changes the rate that we lose apples. So now let's say I make my drop-off point where I have 1,000 apples left. Let's call it x. Basically, I'm making 3 trips, so 1,000 divided by 3 is 333.3333, whatever. And I started with 3,000 apples. So x is going to be like 666.66, basically 667 we can say. At this mile count, we know that on every trip we're going to lose this amount of apples. So we're going to put down 333 and we make 3 trips. So we're going to end up with 1,000 apples at the mile 667. So now notice that I can just load up my donkey with all 1,000 apples now, and we can just go the remaining 333 miles to town B, and we'll wind up in town B with 667 apples. So you can see that we're getting closer to the optimal solution. And you can see that 667 is better than 500, which we were doing previously, but can we do even better? Well, the whole point of me choosing 1,000 apples is that because once I have 1,000 apples, it only takes me one load to get the remainder of the distance, right? So I'm only losing apples at the normal 1 apple per mile, right? I went 333 miles and I lost 333 apples. Versus to get to the 1,000 apple mark, to get to 667 miles, I went 667 miles and I lost 2,000 apples. So I'm losing 3 times the amount of apples as I'm traveling in miles. So now the clear thing to do is look at the point where I have 2,000 apples. Because at this point, I'm making 2 trips, right? Here I was making 1 trip. Before I was making 3 trips. So I should only be losing 2 apples per mile. So now let's find the mile marker x such that 3x equals 1,000 because we lost 1,000 apples and we want to solve for x. So x is going to be roughly 333 and 1/3 miles. So what does this represent? This is basically the earliest point in the journey such that I start only having to make 2 trips to get the remaining apples to where they need to be. So I'm only losing 2 apples per mile now instead of 3. And this is the earliest point where that happens. Now notice what that does. First of all, we can just call this 333. We can round down. Well, there's only 333 miles between these 2 points. We can call them 1 and 2. But if I make 2 trips and I bring these apples over here, I'm only going to lose 333 apples per trip, and I made 2 of them, so I'm going to lose 667 apples, and I started with 2,000, so that's going to leave me with not 1,000, but 1333, right? So in the previous situation, I was unnecessarily losing apples at a rate of 3 per mile, all the way up to the 667 mile mark, when I could have stopped here at 333 miles and only lost apples at a rate of 2 per mile. So in the previous situation, I was losing apples at a rate of 3 per mile all the way up to 667, which I did not need to be. If I stopped at the 333 mile mark, I would have only lost them past then at a rate of 2 apples per mile, right? So from this point to this point, from point 1 to point 2, I lost apples at a rate of 1 apple per mile higher than I needed to, which is why I lost an extra 333 apples in the previous case, right? I had 1,000 here before, and now I have 1,333. But now look at this. Even when I have 1333 apples here, right? This is still going to take me 2 trips to get across. So I'm still losing apples at a rate of 2 per mile. So there's really no point at stopping here anymore, right? Instead, I want to stop when I have 1,000 apples, which is going to be further ahead now that we added that intermediate stop, right? I want to stop when I have 1,000 apples because at this point I'm going to start losing them at a rate of 1 apple per mile instead of 2. So what point X is this going to be? So clearly, since we're making 2 trips from this point, this is going to be 500 miles, right? 1,000 divided by 2 ahead of this point, which was 333. So this is actually going to be at 833 miles now. And now once we have our 1,000 apples at mile 833, we're just going to take them the remaining distance, and we're going to lose 167, but that's still going to leave us in town B with 833 apples. And this is going to end up being our optimal solution, 833 apples using exactly this strategy, right? We take our 3,000 apples in 3 trips until we can fit our apples into 2 trips. Then we take those until we can fit them into 1 trip. And then we just take those to the finish line in order to minimize the number of apples lost per mile. So now notice that capacity is basically the limiting factor, right? If we had a capacity of 3,000 apples, we could take them all in one go and end up in town B with 2,000 apples, right? If our capacity was 1,500, so half of the amount of apples that we have, and we started with 3,000 apples, Well, we could apply the strategy that we just used and get to the halfway point with 750 in one trip and then bring the remaining over, and we'd end up here with 1,500 apples. And now our capacity would be 1,500, so we could just take them the rest of the way and end up here with 1,000. But since our capacity was only 1,000, we figured out it was 833. So the lower the capacity you have, the less amount of apples you're going to be able to get to the other side, which makes perfect sense.